these questions here, they just require mainly application of the cyclic quad theorem. So I'm going to move very quickly here. Okay, very, very quickly. I'm going to also assume that you memorize your cyclic quad theorems. So the first one, okay, let's call that one A, that one B, and that one C. Okay, those diagrams. So the first diagram, I want to determine the values of A. Okay, let's call it 1, 2, 3 because so this will be 1, that's 2, and that will be 3. Right, so we want to determine the letters inside. Okay? So we'll start with finding the value of A first. Now here we have got a quadrilateral with vertices at the circumference, which means we have to use theorem 5. We have a quadrilateral with 4 vertices on the circle or at the circumference. Right? So we say A plus 110 will give us 180, and your reason here, it will be opposite angles of cyclic quad. Okay? So angle A is going to be 180 minus 110, and you get 70 degrees. Okay? So that's pretty straightforward.
Where's the reason?
Okay? The reason is this. You only give one reason here. It's straightforward. Opposite angles of a cyclic quad. Alright? To find B is the same. So angle B plus 80 degrees, that will give you 180, and the reason will be angles, opposite angles of cyclic quad, opposite angles of cyclic quad. Okay, so B is going to be 180 minus 80 degrees, which gives you 100 degrees. Right? So that's straightforward. Okay? But don't expect questions to come like this now. Okay, this is a very simple diagram. You are more likely to get more complex diagrams than this, where you have other shapes. Okay? And I'm just doing this just to show you how you answer the questions on cyclic quads. Okay? Then let's move on to the next one.
I know, wait a
Okay, I need to move on, please. The second diagram, right? We have two exterior angles of a cyclic quad. This angle here and that angle. Okay? And our quadrilateral is this one here. We have a vertex at the circumference, vertex at the circumference, vertex at the circumference, also another vertex. So we have got 4 vertices on the circumference. Therefore, the quadrilateral is cyclic. Okay? And then this line here up to there, from here up to there, it is produced to this point to create this exterior angle. Furthermore, from this point up to that point, it is produced up to this point. So we have another exterior angle. So we have to use theorem 6 for this question. For the first one, we use theorem 5, opposite angles of the cyclic quad. So now we are using theorem 6. So here, angle C, okay, is an exterior angle. It's going to be equal to the interior opposite angle. So just write here C is equal to 102 degrees. Your recent exterior angle of cyclic quad. Okay? Then D is going to be equal to 60 degrees. Your recent exterior angle of cyclic quad. Okay? So that's pretty straightforward. But again, as I said earlier, this is a simple diagram. I'm going to show you a typical question for on cyclic quads. They are always combined with other theorems in a typical question. So I'm going to do such a complex question later on. But this is how you write your reasons for theorem 6. Okay? This is how you write your reason for theorem 6. And this is how you write your reason for theorem 5. Okay, that's how you write it. Okay, let me move on to the third diagram. Can you draw that? We are moving on to the third one. So third diagram. Okay, so with the third diagram, fortunately, I have got my own highlighters. Okay, so for this diagram, can I have one? Can you have one lesson? Now, even though we did the theorem 4 under central theorems, it also applies to cyclic quads. Remember, I told you about its converse being used to prove that a quadrilateral is cyclic. So for this diagram here, you look for butterflies. Okay? A butterfly also forms a cyclic quad. Right? So this is the scenario. We have got that. Fine. Then move on to that. Then go that way, and then you go that way. Okay? So it means angle E is equal to what? Angle E is equal to angle F. Then I don't like people who are negative. Right? And then you use the yellow one. Okay? So the yellow one, okay? Now it tells me that both angle E and angle F are equal to 40, but I'm going to start by saying F is equal to what? Okay, I also have, okay, I can use green too. Okay, so we can also have that. You can also have that. Okay, right? So all three angles are equal. So I'm going to start by saying angle E is equal to 40 degrees. Can you have one lesson? Can you have one lesson? Angle E is equal to 40. My reason here will be angles in the same segment. Okay? Then angle F. Now, I can say angle F is equal to angle E. They are both equal to 40. The reason angles in the same segment. Okay? Alright, so this is pretty simple. Right. So the next page I'm going to move on to a more complex question. Right, let me carry on. Can I move on?
So can you not just put FE 40 once that's like
Okay. I would not encourage you to do that because you have more than one butterfly. So find effect following the English alphabet. We know that based on that there is another butterfly which connects E and F, that's why I wrote the second step. If you write in one, you may disadvantage yourself in an examination situation. Yes? No, you can just write F equal to 40. But here I said F is equal to E so that you are aware that those two are angles in the what? Same segment. But what is E? 40. If you write F equal to 40, it's also acceptable if you give that as your reason. Alright. Can I carry on? Right. Let's move on. Right, I'm not gonna do this one, please. Okay, you can do it. I'm gonna do a typical examination question, which is that. Right, this we have one lesson. This is a typical question that you can get in an examination. Okay, you get a cyclic quad, yes, but there will be other geometry concepts that you also need to take care of. Right? So according to the diagram, we are given the center, right? The moment there is a center, it means you might need to use one of the center theorems. Then we are told that PWSR is a cyclic quad. So this is a cyclic quad. Okay? So that's a cyclic quad. Okay? Because the four vertices are on the circumference. Then PW is parallel to OS. Okay, so let me indicate that. I clicked something which I wasn't supposed to click. How did this diagram end up being there? Okay. So we're supposed to have that. Okay. So it's supposed to be like that. I think there's something which I clicked which was not supposed to be clicked. Alright. So let me indicate with that one. So we have PW being parallel to OS. Like that. Okay? Obviously, we have this angle here, P1 equal to 36. Okay? Yeah. Now, whenever you get questions on geometry, you must know what to look for. Right? First, you must check if there is a center. Okay? Can you pay attention? You must look at the diagram if there is a center. If the center is there, it means you have to use one of the four center theorems. But if the question is on angles, theorem 1 is out. It means you're left with theorem 2, theorem 3, or maybe theorem 4. But theorem 4, there has to be a butterfly. If the butterfly is not there, theorem 4 is out, theorem 1 is out. We're left with theorem 2 and theorem 3. Theorem 3, you must have a diameter. If the diameter is not there, theorem 3 is out. We're left with theorem what? 2. Are you following that? So identify the center first. Then use elimination based on the given question. Right? So you check for centers. Obviously, you must also check if there's a diameter. Okay, at this stage, I can't write radius based on this question. Right? Then you need to check for cyclic quads. Then you need to check for lines that are parallel. If you have got a question with lines that are parallel, it means that you might need to use alternate angles, co-interior, or you might need to use corresponding angles. Okay, that's geometry of straight lines from grade 8 and 9. Right? Then triangles. Triangles are a major part of your geometry. Because we know that the three interior angles end up to what? 180 degrees. Don't be scared because of the question, of the diagram. Okay? Ask yourself, what information do I have? Okay? Right? So here, if we want to calculate SOW, right? So this is the angle. We have got SOW. SOW, so that's the angle there. It's an angle at the what? At the center. Which chord subtends it? Huh? It's what? It is subtended by WS. Does WS subtend any other angle? Huh? Subtends what? P1 at the circumference. So angle at center is 2 times angle at what? Circumference. Okay? So allow me to just duplicate this because I need to talk about each question separately. Right? So 7.1, that one there, SOW is going to be equal to P1. They are both equal to 30. Sorry. So this will be 2 times P1. SOW is going to be 2 times P1. The reason of the angle at center is equal to 2 times angle at circumference. So that will be equal to 2 times 36 degrees, which gives you 72 degrees. Yes. I thought you wanted to say something about the question. Okay. Are you following me? Yes? No. Thank you for bringing that up. Right here, there is a butterfly, yes? This one here. Let me use the highlight. Maybe that one. Okay, so this is like a butterfly, yes? That one there. But there's one problem. This angle here is not at the circumference. Okay? Not at the circumference. One angle, that is angle SOW, is not at the circumference. Therefore, we can't use theorem 4. We can't use theorem 4 because one of the angles is not at the circumference. That is, our SOW is not at the circumference. You only use theorem 4 if both angles are at the circumference. Can you two stop that and pay attention? Stop that and pay attention. I need your whole being. No, this way here. You pay attention. Every cell of you, every atom must pay attention. Okay? Alright. So let's carry on. Right? So I've done that. Let's move on to the next one. Right? W2. So we use our highlighter. We go to where W2 is, so it's this angle here. Okay? Now if you look at it, PW is parallel to OS, and we found this angle here. And there's a transversal which connects W and O, which means these two angles are equal because they are alternate angles. Okay? So that one. So say 7.2, say W2 is equal to OSW. Sorry, it's the other way around. It's SOW. Right? Why are they equal? Because they are alternate angles. Once you state that lines, okay, you state that angles are alternate, you have to write down the lines that are parallel. So here it's going to be PW is parallel to OS. If you don't state this, your reason is considered as incomplete, therefore incorrect. Okay? Alright? So we're done with that one. Right, then OSW. Okay, so let's identify where it is. So we've got OSW, which is this angle here. That's sum of S1 plus what? S2. Okay? Now, to get that angle, it's not that complicated. Okay, we just have to use triangle WOS. So I'm going to move on to the next page. Okay, let me duplicate this because I need to do the last one. And so we are doing that one now. So 7.3. If I want to calculate the size of OSW, I need to use triangle WOS. Okay? Now this is how I'm going to do. Before I carry on, I'm going to write in triangle. Okay, by writing in triangle and specifying the triangle, it indicates that I know what I'm doing. I have identified the triangle which is going to help me to determine the size of that angle. So write down the what? The triangle. Is it you whom I told about perception? Perception when someone is marking your work. I told you, right? So there's no mark allocated for this, but it helps whereby when I'm looking at work to see that you know what you're doing. Right? So I've identified the triangle. Now before I go anywhere, I'm sure you can agree with me about this. OW is a radius, OS is also a what? A radius. So I need to write here, these two are equal and they are radii. Okay? That's important. Then I'll say, right? So I'll say SO. Okay, before I do that, anyway, let me just write this down. So because of this, angle W1 is going to be equal to WSO. And the reason will be their angles opposite equal sides. Okay? Are you following that? Huh? Okay, then from there now I'll say, if I add W1 plus WSO plus angle SOW, I'll get 180 degrees. And my reason here, sum of angles in a triangle. Okay? Once I have that, now because of this statement here, that statement there, I can replace the W1 by OSW, which I wrote as WSO. Please take note here, this is the same as that. It's the same. It's just that I switched the W and the O based on that. Okay, it's the same angle. Okay? So I can replace them. If I replace them, then I can say, therefore, 2 WSO is going to be equal to, I know this one here, the SOW, so this will be 180 degrees minus, what value did we get? 72, so that will be 72 degrees. Right, allow me to move on to the other side. Let me take out this. Okay, I won't interfere with anything there. So I'm going to remove that. Right, then I'm going to carry on from here. So this goes all the way to the top. Okay? So once I have that, I'll have 2 WSO is equal to 108. Sorry, 9. That will be 108. 108, yeah, 108. So that will be 108 degrees. So OSW is going to be equal to 108 degrees divided by 2. And that will give you 54 degrees. Okay, yes.
Instead of saying WSO, would you get it wrong if you said angle S?
That will be incorrect because there is another small angle here. There's another small angle. So if you say angle S, it means your naming will be incorrect because this small angle is also part of the whole angle WSR, which you can call angle S. Okay, so what I would suggest there, maybe you name, there's S3 here, by the way. There's S3 there. So your angle S is what? S1 plus S2 plus S3. It's not equal to S1 plus S2. You hear what I'm saying? Angle S is equal to S1 plus S2 plus S3.
Okay, but so when you say W1 equal to W2 S2,
Okay. This is very simple. So the angle that I'm talking about is this one here. It's this angle. This color would be better. Maybe. So it's this whole angle here. Right? You stop here, then you go down along the radius. That's the thing.
So, but like in another case, it wasn't like this. You just say the angle instead of using the whole triangle. Like what she's talking about, like if there was a case where it wasn't triangle.
For this case, you can't call this angle S, because there's also that S. If this line here was along this line, that's when you could call it what? Angle S. But in this case, you can't, because there is another angle S3. Okay. Can I carry on? Huh? Right, so let's do the last part. Then, but here's got a question. Alright, I'm going to assume that there's no question, so let's move on to 7.4. So 7.4, we have angle R, which is that. Okay? Now, to get angle R, the best way is to use opposite angles of a cyclic quad. That's the best way. Okay? Unfortunately, we don't know the size of this whole angle, but we know the size of W2, obviously. So we know that W1 is equal to that angle. We have found it from here, right? They are equal. So what that means is, I can say, now we have to start from somewhere. Say W1 is equal to 54. So we proved this. Right? Prove this in 7.3. Okay? And then W2, we proved that already. Am I right? And what was the value of W2? Huh? 72. So we say we proved this in what? 7.2. Okay? So what this means is angle W is going to be equal to 54 plus 72 degrees. Then this will give you 126. Okay? But PWSR is a cyclic part. Therefore, angle R plus angle W, they add up to what? 180. And you give your list in here, opposite angles of cyclic part. Okay? So what this means is angle R will be 180 minus 126 degrees, and you get what? 54 degrees. Okay? And then that's it.